Okay. So let's look at the first question. Okay, we have two types of spring. We have spring A and spring B. Okay, and both spring have different extension when one 10-gram weight are hung on them. Okay, so you need to calculate the total stretch in each of the spring system. Sekejap ya, saya buka satu lagi. Okay. Oh, lama. Sorry. Okay, so let's look at spring A. Diagram A. So what is the total stretch for diagram A? Anybody want to try and answer? Okay, we have A and B arranged in series, and we have 20 gram of weight hang to it. So anybody want to try and answer? Question A. If you don't want to on your speaker, your mic, you can write the answer in the chat area. Okay, Sutas 12 cm. What about the others? Vishini also 12 cm, Abi also 12 cm. Okay, so most of you answered 12 cm. So let's look at the solution. Okay, yes. Okay, very good. Both spring A and spring B will experience the 20 gram weight. And for spring A, for every 10 gram, the extension is 2 cm. Therefore, when 20 gram is hanged, the extension will be 4 cm. Okay, whereas for B, spring B, the extension will become 8, and we need to add both extension A and B, and we get 12 cm. Okay, very good. And then let's look at B. So what is the extension for B? And B, we have 50 gram of weight. So what is your answer? Yes. Okay, so that's 10 cm. What about the others? Also 10 cm. Okay, so all the answers are 10 cm. So let's look at the solution. It's 5 cm. Okay, so let's look at diagram B. Okay, we have two spring in parallel. When we have two spring in parallel, what happens is the weight will be divided equally between the spring. So from 50 gram, spring A will get 20 gram, 25. The other spring A will get 25 gram. Okay, so since every 10 gram, the extension is 2 cm. So when the weight is 25, the extension will be 5 cm. Okay. So 10 gram extension 2, so 25 extension, you don't know, so we use the proportion. Okay, so now what about diagram C? What is your answer for diagram C? We have B arranged in parallel, and both B in parallel is arranged in series with one spring A. So what is the answer for uh, diagram C? 8 cm. Okay, what about the others? 16. Anybody? 16. Okay, the rest is answering 16. Okay, so let's look at the solution. The answer is 16 cm. So when it is arranged in series, so this one get 40 gram, and the next spring, the upper part yang B in parallel to 40 gram. However, the B is connected in series. So dia dapat 20-20 lah. Dia akan dibahagi sama rata. Okay, so from there we can calculate the extension. Okay, so for C, the extension is 16 cm. Okay, very good. Now we look at the next question. The original length of a spring is 12 cm. With a load of 20 gram, the length of spring is extended to 15 cm. What is the elastic potential energy stored in the spring? So, how do we calculate elastic potential energy? If we have a graph, F over X, okay, directly proportional, the elastic potential energy is the area under the graph. So what is the formula? Okay, if it's a graph, but the graph is not given here, so what is the formula? So if you look at the graph, what is the formula for area under the graph? Half kx square. Okay, so there are two methods to calculate elastic potential energy. One is area under the graph, which is half fx. Okay, or we know from the graph, the formula, the linear graph formula is f equals to kx. So if we substitute f equals to kx in this formula, the next formula is half kx squared. Okay, both are the formula to calculate elastic potential energy. Okay, so let's look at question number 5 here. So what is the elastic potential energy? What did you get? Okay, we know that we have two formulas to calculate. So based on the question, which formula that we can use? Which formula is easier for us to use? Okay, so what is your answer? Okay, we have the original length of the spring is 12 cm, and when we put 20 gram load, the length extended to 15 cm. So how much is the elastic potential energy? And we know there are two formulas to calculate the elastic potential energy. Which one is more suitable based on the question? (300 joule), 0.2943. Wah, macam-macam jawapan. Okay, 0.03 joule. Okay, for Kalpana and Abi, um, hold on, different answer. Okay, kita tengok dekat chat ada banyak-banyak jawapan kan. Okay, so which formula is suitable? I think you are using this formula kan? Okay, half fx kan? Half fx. Yes. Okay. So we have 20 gram. And 20 gram is not f. 20 gram is the mass. So what should we do? For the 20 gram, change to Newton. Okay. So where Newton is the unit for force, and the load here, the force is weight, so mg, and the mass is 20 gram, so we need to convert to kg. Okay, so 20 gram per tukar kepada kg is 0.02 times 20 divided by 1000 kan. 20 divided by 1000, 0.02, banyak. Kita lebih 0.02 k times k. If we refer to kbsm, the G is 10. Okay. However, if I look at the latest formula given in front of the paper, the exam paper, G is written in the formula, and the value of G is 9.81. Okay, so for when the G is given in the formula, dekat depan tu kan ada formula kan, and G is given as 9.81. So for the rest of the question, G we need to use 9.81. Okay, so it should be 9.81. So times 9.81 is 0.1962. Okay, so the weight here is the force. What is the extension? We have the F, and what about the X? Berapa extension dia? 3 cm. So should we convert it to meter, or should we just leave it as cm? Okay, so 3 cm. So if we convert it to meter, 100, it will become 0.03. Okay, so using the formula, half fx 0.162 times 0.03. Okay, so times 0.162. So the answer is 0.1962 times 0.03. Betul tak? So 5.886 times 10 to the power of negative 3 joule. Okay, and actually, if you don't want to convert cm to meter, also can, but your answer would be 0.1962 times 3, 0.5886 Newton cm. Okay, so this is what I tell you about units. Okay, if you want to use the SI unit, which is joule, everything for the calculation for that particular physical quantity need to be in SI unit. Okay, if you choose joule as your final answer, so everything must be in SI unit. The F must be in Newton, X must be in meter. However, if you don't want to convert the meter, you can write your answer in that unit. Newton cm. Okay, so this is oh, terlupa. Half. Patutlah saya punya jawapan pelik. So half. Tak ada siapa pun cakap apa-apa. So dia jadi 0.00586 divided by 2 0.00294. Yes. Okay, or 294 times 10 to the power of negative 3. Okay, for this one, because this is for the KBSM punya PowerPoint, so we still use 10. Okay, but for KSM, if I refer to the formula in front of the question paper, dia dah bagi awal-awal G is 9.81. Okay, let's say if you receive your exam paper and then at the formula, it does not mention anything about G. Okay, dia tak bagi tahu pun G is 9.81. Tapi dalam soalan, dia ada bagi G is 10. So you follow the question. Okay, so firstly, you have to look at the formula. What is the G given? What is the value for G? And if it's not mentioned in the formula, you look at the question. If it is not given in the question and it's not in the formula list of formula, then you can choose any value for G. But for me, I think under KSSM, it's better for you to use 9.81. Okay. So, any question on question number 5? I think most of you get it okay, but maybe because you did not convert the unit, that is why your value is different. Okay. So, when you calculate any physical quantity, you need to look whether you want to use the SI unit or not. Okay, let's say if you don't want to use the SI unit. For force, you cannot. Tak boleh. Sebab force, Newton. So, everything must be in SI unit. Kalau awak tak tukar kepada SI unit, nanti unit awak akan jadi gram, cm, negative 2. So, CMS negative 2 nanti dia complicated. Okay, so for force, memang kita tukar kepada Newton. And then for X, you can use either Newton or cm. But if you choose to use cm, your answer should be in Newton cm. Okay? Okay, so now let's look at the next question. Figure shows a graph of force F against extension X for a spring. What is the potential energy stored when the spring is extended? Yang ni kita dah tahu dah. We have a graph. The graph is F over X. So we are to calculate the potential energy stored when the spring is extended by 0.4 meter. So what is the potential energy? Berapa? Dah kira belum? 4 joule. Okay, since the F and the X is in SI unit, so we don't have to convert anything. We simply use the formula half Fx. Okay, so we get 4 joule. Okay, very good. This is a straightforward question, no conversion, nothing. So you should get the correct answer. Okay, let's look at number 7. Okay, number 7. Previous example or previous question is extension. For spring, we can either extend or we can compress. So when we compress, the spring will become shorter. Okay. Figure show a ball of mass 1 at 10 gram pushed against one end of a spring on a smooth surface. The original length of spring is 10 cm. Okay, so this is the original length, this is the mass, and we are given the spring constant. And A, determine the elastic potential energy stored in the spring. Okay, so the difference between the first question, the spring become longer. But now, because it is compressed, the spring become shorter. Okay, so here what formula is suitable to use to calculate the elastic potential energy? Now, which formula? Yes, A. Which formula? Oh, kenapa saya pun dia tak jalan lah? Okay, so half kx square. So we use half kx square. So you get 0.16 joule. Okay, so we have this one dia kira siap-siap F dulu, lepas tu baru dia masukkan dalam formula. Or we can straight away use the formula E equals to half kx square. Saya punya ni dia tak nak automatic bergerak. Saya tak nampak jawapan. Okay, so untuk A tak ada masalah kan? Straight away we substitute the value into the formula. And before we can substitute the value, we must make sure all the unit is in SI unit, because the spring constant is meter and the length of the spring is in cm. So itu kena tukar kepada meter. Okay. So B, the maximum velocity reached by the ball after the compression force on the spring is removed. Okay, so in your form 3, in your lower form, you have learned that we have what we call as conservation of energy, the law of conservation of energy. So what does the conservation of energy state? Dia cakap apa? Conservation of energy. What does conservation of energy state? Yes. Kalau rasa panjang nak tulis dekat chat, buka mic je lah. Law of conservation. Sebab form 4 kita tak belajar energy dah. Sebab tadi ajar masa menengah rendah. So dalam menengah rendah kita ada law of conservation of energy. Energy cannot be created or destroyed. It can be transformed from another form to another. Okay. So here we have a spring. We compress. So the spring store elastic potential energy. When the spring is let go, when we let go of the spring, the ball move forward. Okay, so what is the conversion of energy when this occur? Lepas kita compress and then we let go, energy convert from what to what? When the spring is compressed, elastic potential energy, and then when it is let go, it convert to kinetic energy. Very good. Okay, so who knows what is the formula for kinetic energy? How do we calculate kinetic energy? Ingat lagi tak? Siapa ingat? How do we calculate half mv square? Okay, very good. So now, Based on the principle of conservation of energy, we can convert energy from one type of energy to another. So here, elastic potential energy is converted to kinetic energy. So we have calculated the elastic potential energy in A. So kita masukkan di dalam sini, equals to half mv square. Okay, so we get the V value as 5.66 meter per second. Okay, but in order for us to use the principle of conservation of energy in our calculation, elastic potential energy equal to kinetic energy, we have to make assumption. What assumption do we need to do? Apa yang kita assume? Ataupun apa yang kita andaikan in order for us to use this elastic potential energy equal to kinetic energy? There have to be a certain assumption made. No energy lost to the surrounding. Okay, so elastic potential energy equal kinetic energy if there is no energy lost to the surrounding. So we need to make that assumption. Otherwise, we cannot use this formula or we cannot use this concept. Okay, so far for question number 7, boleh follow? Or do you have any question on question 4, 5, 6 up to 7? Boleh ya? Ada soalan tak? Okay, if we have no question, let's look at number 8. Dah buat belum soalan nombor 8? Sekejap ya. Okay. So, we have 3 identical spring, okay, P, Q, and R, and the spring constant is given 4 Newton cm to the power of -1. The arrangement is compressed by an 8 Newton force. So you are to write the force experienced by each spring. So berapa force experienced by P, berapa force experienced by Q and R. So berapa? P berapa, Q berapa, R berapa? Yes. Okay, PA, Q, Q4, and R4. Okay, very good. So PA, Q4, R4. So since we know the force experienced by each spring, so what is the compression for each spring? P berapa, Q berapa, R berapa? Berapa compression for each spring? Okay, Q4, R4. Okay, this is the force. As for the compression, P 2 cm, Q 1 cm, R 1 cm. Okay, so we have Abi, we have Jasmine, we have Yoshini's answering question B. Okay, so P 2 cm, Q 1 cm, and R 1 cm. So C, compression of the whole system. So the whole system, what is the total compression? Berapa cm? 3 cm. Okay, any other answers? Semua jawab 3 cm. Okay, yes. Because this 2 and this is 1, so the total compression is 3 cm. Okay, very good. Okay, so now let's look at the objective question. Question number 1. What is the answer? A. Okay, everybody's answer is A. So let's look at the answer. It is A. Okay, very good. Okay, so now let's look at question B. Okay, sorry, question number 2. What is the answer for question number 2? Okay, D. Okay, everybody answered D. So it is correct. So question number 2, the answer is D. So let's look at question number 3. Okay, D. Question number 3. Abi answered D. Nadia answered D. Yoshini answered D. Okay, Kalpana also answered D. Okay, everybody answered D for question number 3. So the answer is correct. It's D. Okay, so if you are not sure how to calculate the extension, so this one, the extension is X, it is X, this is X, so the extension is 3X. And here is X, this is half X, so 1.5 X. So this is 1 over 3X. So the extension is 1 over 3X. So the comparison of extension is R bigger than P bigger than Q. Okay, very good. So let's look at question number 4. What is the answer for question number 4? A. Okay, so everybody answered A. So the correct answer is A. Okay, if you look at the graph, the gradient for X is bigger than gradient for Y. So from here, we can make conclusion that X is harder or stiffer than Y. Okay, so continue to question 5. Okay, which comparison of the length of spring is correct when weight of 1 kg is hang? So which one is longer and which one is shorter? Question number 5. Okay, Suta's answer is B. What about the others? Okay, Jasmine also answered B. Okay, so most of you answered B. So let's look at the answer. The answer is A. Okay, so now let's look at the how do we calculate the extension or the length. So this one is 1 kg. So we have two spring in series, but it is arranged in parallel. But firstly, we need to solve the parallel arrangement. So this part will have half kg. This one will have half kg. So this half kg, half kg. So total is 1 kg. Okay. Whereas for Q, this one will get 1 kg. This one will get 1 over 3. So for Q, the total is 1 over 3. Okay. So for this one, it's 1 kg but divided into 2. So here is half. This is 1. 1 over 3. Okay. So if we look at the extension, P, it means 1 over 2, sorry. Okay, P is longer than Q, longer than R. Okay, so the answer is A. Okay, any question on number 5? Boleh tahu? Boleh faham tak? Yes. Yes, Kalpana. How to calculate for R? Okay. For R, firstly, we have 1 kg load. Okay, and the 1 kg load is being divided equally between two parallel springs. Okay, so ni akan dapat half. Ni akan dapat half. However, the spring is, ada satu lagi spring yang arranged in series kan? So this will get half, this will also get half. Faham tak? Okay, if you have a spring in series, kalau kita ada satu, so this one get 1 kg, this one also get 1 kg. So firstly, dia divide dulu. Dia divide dulu sebab beban tu dipegang oleh dua yang secara parallel kan. So dia divide dulu siap-siap. So 1 kg, half kg sebelah sini, half kg sebelah sini. Tapi lepas tu half kg tu dipegang oleh satu spring and then satu lagi spring di bawah. So both spring will have half kg. So bila kita total, dua-dua ni akan dapat 1 kg. Okay, boleh Kalpana? Okay. So boleh why it is A not B? Okay, so we go to the next question. Okay, so this is structure question. We have a diagram show the arrangement of an apparatus in an experiment to determine the relationship between extension of a spring T with weight W. The relationship of E with W, E ke X is shown in the graph in diagram 3.2. Law states that extension of the spring is directly proportional to the force applied if the elastic limit does not exceed it. So, what is the name of the law? Apa nama? Hooke's law. Okay. So, since this is the name of a person, your answer should be H-O-O-K-E apostrophe S. Okay. If you don't want to put apostrophe S, leave it as H-O-O-K-E. Okay, Samitra, it is not H-O-O-K-E-S. If you want to put the S, you put apostrophe S. Okay, and it is also not H-O-O-K apostrophe S. Dia ada E. So, kalau tak sure nak letak apostrophe ke, tak payah letak apostrophe. Okay, this is a person's name. Wrong spelling for this law, wrong answer. Okay, so any law, Archimedes, Bernoulli, Hooke's law, apa-apa sahaja law yang menggunakan nama orang, the spelling must be correct. Okay, so in the future, kalau tak sure nak letak apostrophe S ke tak, letak nama dia saja, tak payah letak apostrophe. You won't be penalized for grammar mistake. Okay, sebab ni bukan English, ni physics. Okay, so Hooke's law. Tak nak letak apostrophe S pun boleh. Tapi kalau apostrophe S tak ada, salah. And buat H-O-O-K-S, dah salah. Sebab ini salah ejaan. Okay. So might as well you write H-O-O-K-E saja. Tak payah letak S. Boleh? Okay. So Hooke's law. Lupa dah jawapan dah ada. And then on graph, mark the cross, the position of elastic limit of the spring. So part yang mula tak follow directly proportional, kita panggil dia sebagai part of elastic limit. Tanda kat sini dia tanda lari sikit. So kalau dalam exam tanda betul-betul dekat graf. Yang ni sebab nak tanda tu susah. Sebab ni PowerPoint kan. So nak betul-betul atas line tu susah. Tapi bila exam, put it exactly on the line. Okay, B. The spring stores energy when it is extended. Calculate the energy stored in the spring when it extends by 4 cm. Okay, so berapa? Kira. Berapa dapat? Yes. 250 Newton per meter. Newton per meter. Are you sure the unit is correct? Sutas? Newton per cm. Are you sure your unit is correct? Energy stored. Okay, energy stored is represented by gradient pula. By area under the graph kan? So 4 cm. Okay, this is 4 cm. Okay. So area under the graph. Jadi answer is 0.2 joule. Okay, half kx. Half this one times 10 times 4. 4 cm. Kalau tak nak buat joule, dia boleh jadi 20 cm. Dan saya kata kalau tak nak tukar unit, but you cannot write joule lah. Awak buat dia 2 cm. Okay? Boleh? Okay, the spring store energy when extended, calculate the energy stored. Dia nak energy stored. And we have a graph. So, if we have graph to calculate energy, elastic potential energy stored, it is area under the graph. Tapi kat sini dia guna formula. So, sama je. Sebab daripada area, you are using the same formula. Okay, which is F times X. Cuma dalam kes ni ialah W dengan E lah. Dia tak guna F, dia tak guna X. Okay, so boleh? Boleh? Sebab saya tengok kat sini, saya tanya kat sini. Tapi awak nampak saya kat sini. Confusing. Okay, so any question? Dan satu lagi. Kalau awak tengok, markah 3 kan? Okay, where are the mark given? The first mark, since you are given a graph, so the first mark come from area under the graph. Maksudnya awak tunjuk dekat graph tu. Okay, awak extrapolate daripada 4 pergi ke graph. Okay, and then lorek-lorekkan. Okay, so that is the first mark. The second mark is substitution of the, yes, Sukas. And lastly is your answer. 3 markah. It's written as question C. Oh, So yang B itu apa? Oh, ada soalan lain ni. Oh, tertinggal soalan tu. Okay, so patutlah semua bagi unit dalam Newton per cm. Yes. Kalau determine force constant, so it is correct lah. Okay, so it depends. Kalau in Newton per meter is 250. If it's Newton per cm is 2.5. Okay, so sorry because this saya tak perasan. Ingat macam sama, macam dah ada semua soalan. Apa rupanya ada tertinggal. Okay, so harap maaf. So this is question C, is it? Okay. So question B patutnya satu lagi soalan, which is the force constant or the spring constant. So if the question asks the force constant or the spring constant, it is the gradient. Okay. So markah dia berapa dalam soalan tu? Berapa markah? 3. Oh, tak ada markah. Okay. So kalau markah dia 3 juga, you have to the first mark is from the graph. Awak kena buat segitiga. Okay, segitiga paling besar. 5 kotak paksi Y. 1, 2, 3, 4, 5. Okay, 5 kotak paksi Y, the minimum. Paksi X, 1, 2, 3, 4. Okay, so that is the first mark for the gradient. And then the second mark is substitution. Masukkan value dan the final mark is your answer with the correct unit. Okay, it is this is especially for eksperimen. Kalau eksperimen memang kena gunakan kaedah ini. Okay, so never mind. Let's continue with C. Yang ni soalan ni ada tak? Okay. Another spring identical to spring T is added to the arrangement. This new arrangement is shown in diagram 3.3. The experiment is then repeated. Sketch the graph W against E for this experiment in diagram 3.2. So pada diagram yang sama ni, sketch kalau kita ada satu lagi identical spring arranged in parallel. What do you think will be the graph? What is different between this graph? Which part is different? Will the gradient be bigger or will the gradient be smaller? Dia akan lebih stiff or dia akan lebih landai? Lebih steep or lebih landai, maka stiff. So what would be the graph? What would be different now? Apa yang akan berubah? Sekarang kita ada dua spring in parallel. How would the graph be? Dia akan jadi lebih curam atau dia jadi kurang curam? Steeper. Okay. Force will reduce. Kapan macam mana? Apa maksud awak force will reduce? Ini ada tanda soalan sikit lah. Bila kita jawab force will reduce, apa maksud dia force will reduce? Okay, Jasmine answered steeper. The weight is divided by the two springs. Yes. So what will happen to the extension? Okay, each spring will get smaller force. Yes. Okay, so if we draw the graph, okay, this is the original graph. So as for the new arrangement, the graph will be like this. the graph will be steeper. The gradient will be bigger. Okay, why? Because as Kalpana said, each spring will get less force. So even though you add more force, each spring will get less force, so the extension will become smaller. So you need to give to put bigger force so that you get the same extension of as the first arrangement. Okay, so dia akan jadi lebih stiff. Sebab spring tu sekarang jadi lebih keras. Okay, kenapa? Sebab the force is divided now. The force is reduced. Dia bukan kita reduce force, but the spring is experiencing reducing force. Okay, so boleh? Question C. Any question on this? Boleh follow? Okay. So now let's look at question number 7. Okay, so we got answer can. Okay, this is the last question we are going to discuss because dah nak pukul dah pukul 9.50. Okay, never mind. We are going to discuss this question on our next class. Jadi saya nak awak jawab dulu soalan yang saya bagi, yang the rest. Okay, nanti kita akan discuss dalam kelas. So I hope that you are prepared with the answer. Okay, so saya kena bagi awak break 10 minutes before your next class. Okay, so with that, thank you class. Okay. Okay, thank you everybody.